11.8. So like we did in the last chapter, of course we don't always know the population standard deviation, and so when we don't, and often we won't, most times we won't, then we got to make adjustments. And these equations are starting to look really long, but I want you to keep that in mind, that that's all they are, is really long, right? Okay, so we know the standard deviation of the samples, right? So we should always be able to figure out probably the standard deviation of the samples, but we don't know the standard deviation of the population. And so what do we do? Well, we use the old t-statistic like we did in the past, but we have to figure out the variance. I think they maybe give that a different call. Yeah, they call that the pooled variance, right? The pooled variance of our sample standard deviations. That's a mouthful. I'm here to tell you. So let's first do what it asks us to do, and once again, read carefully. It says, 1, we got to state the decision rule, compute the pooled estimate of the population variances, compute the test statistic. D is state your decision about the null hypothesis, and E, estimate the p-value. So in this case, they give us our hypothesis, and I put it here as well. You wouldn't have to, but they give that to us, and so now we have to let's do the first part, right? We got to state the decision rule. Well, how do I get this? Well, let's figure it out. Okay, so it's the 0.05 significance, and I'm equal, and so I'm at a it's two-tailed, right? Okay, my degrees of freedom are pooled as well, and so what I have to do, I've got 10 observations and 8 observations, or my sample sizes are 10 and 8, right? And so my degree of freedoms, this isn't equal to 16 times 10, it should be 16. Okay, I just kind of have that. This is how I've calculated that. It's equal to 10, my two sample sizes, 10 plus 8 minus 2, so my degree of freedoms is 16, and again my significance is 0.05, and I should have had up there my t-table. Okay, so degree of freedom, 16, two-tailed, 0.05. Is that right? Hopefully it's 1.746. Oops, no, two-tailed, I'm sorry. 2.12. 2.12. Okay, this should be a plus or minus that if I'm not mistaken. Yep, there we go. So I reject t if it's greater than a positive 2.12 or less than a negative 2.12. And then it says B, it says compute the pooled estimate of the population variances, and so that formula is 11.3 or whatever. It's on page 356, and it's this formula here, right? So the S2 stands for my variance, and again, it's just a long deal, right? So I got n sub 1, or my sample size 10 minus 1, so 9 times my standard deviation of that sample squared. Okay, and that should be S sub 1. I couldn't get the little sub 1 in there probably, but that should be S sub 1, okay, which shows up in yours in the book. Okay, so it's 9 times 4 squared, which is 16, so 9 times 16 plus, then this is going to be my n2, or 8 minus 1, so 7 times 5 squares, so 7 times 25. Okay, so that's the top. I probably have that here, would be my guess. I've got this is the first one, I think, and this is the second one. Is that right? Yeah. Yep, I think that's right. This is probably the bottom, which is basically just my degrees of freedom, right? N1 plus N2, so 10 plus 8 minus 2. Okay, so then it would be this plus this divided by this gives me my pooled variance, right? And that's what I have there. I said this is simply equal to my 144, and again I got that from the first half of the top, okay, plus the second half of the top, okay, and I'm going to need parentheses around those. and then divide that by the bottom, or my degrees of freedom. Okay, so I end up with 19.9375, and there's my answer for B. Then it goes on to say, okay, C is compute the test statistics. So now I got to calculate my t-value, right? And my t-value is nice. It starts here with the difference between my means, my mean 1 minus my mean 2, so that's going to be 2, right? Oh, my means, I'm sorry, I was doing my sample size, so it's 23 minus 26, so it's going to end up being minus 3, okay? But then I've got to do my pooled variance, which I know, okay, times 1 divided by my sample size plus 1 divided by my second sample size, right? So my bottom of the equation, and I've done that a little bit longer, I'd probably maybe I'd break it up a little bit. I'd say this is, equal to 1 divided by n1, and this is equal to 1 divided by n2. Okay, and I've got to add those two together, so this is equal to, this one plus this one. 0.225 times my pooled variance, right? So this is equal to this times my pooled variance. Okay, so now I've got inside the square root, right? It's the bottom of the equation, but inside the square root is equal to 4. Let's see, bottom of equation, inside SQRT, inside the square root, right? Okay, and then I take the square root of that. So this was simply equal to that. I kind of did the equation a little bit longer up there, and that's fine. You can certainly do that. And then I take the square root of that. Simply use my square root function up here is probably the easiest way to do it, but you can do it the other way I showed you as well. Boom, I've got that. Okay, so now I have to take my top of the equation divided by the bottom of the equation, so that's just simply equal to my minus 3 divided by my, and I come up with a minus 1 point. Okay, now is that greater than 2.12? No. Is it less than minus 2.0? It's greater than, right? Because if you're in the minuses, it'd have to be bigger, so I cannot reject the null. Okay, I cannot reject the null, which is that they're equal, right? Okay, so do not reject the null. I accept it. Okay, I don't accept the null, I'm sorry, but I do reject the alternate, that they're unequal, but I cannot reject the null. Okay, and the p-value is greater than 1 and greater than 0.1, I'm sorry, and less than 0.2. So somewhere between a 10 and 20% chance, right, that it would fall outside of that. Somewhere between a 10 and 20% chance that it would fall outside of that. And that's all the information we have. It doesn't really give us a lot of stuff, I guess. So there you go for 10-8.